A new theorem, children. Theorem of internal division of chords. Theorem of internal division of chords. Like if two chords of a circle intersect at a point inside the circle, then the product of the divided parts of one chord is equal to product of the divided parts of other chord. Now, what does it mean, children? If two chords of a circle intersect at a point inside a circle, like suppose this is a circle and these two chords are intersecting inside a circle somewhere, okay? You can see here, children, these two chords are intersecting at a point inside a circle. You can see, suppose this chord, you name it as AB and you name this chord as CD. You name this chord as AB and you name this chord as CD. And they intersect at P inside a circle. Now you can see chord AB का divided parts क्या है? Because of this internal division, P is a point of internal division. It is dividing chord AB into two parts, PA and PB. What will be the product of these parts? PA into PB. P is dividing chord CD into two parts. Which are the two parts? PC and PD. What will be the product of these parts? PC into PD. Now, product of the divided parts of one chord, PA into PB, is equal to PC into PD. This is what the theorem says. If two chords of a same circle intersect at a point inside a circle, then the product of the divided parts of one chord is equal to product of the divided parts of other chord. Suppose this is like, if this, I don't think it should be asked in a statement form, but it may be coming in the given form. Okay, given, got it, chord AB and chord CD of a circle intersect at point P inside the circle. You have to prove that product of the divided parts of one chord, PA into PB, is equal to PC into PD. Now, very simple, children. You have to prove this PA into PB equal PC into PD. So anybody would have guessed it, okay? Very easy. Very easy means very easy. The last line should be this, PA into PB equal PC into PD. So the second last must have been a ratios equal, ratio involving the segments, so that you cross multiply and get this answer. How to get the ratios equal, children? By proving the triangles similar. So how to get the triangles? Like you can draw AC. Just here, I draw AC. I draw BD. So this is my construction, okay? I do a construction. Why? Then only I can get my triangles. You can see here, construction, draw. Construction is what, children? The dotted line what I draw on, okay? Draw segment AC and segment BD. Now, when you look at it, children, proof, okay? Draw segment AC and segment BD, proof. Please here, look at this triangle PAC and triangle PDB. In triangle PAC, okay, and triangle PDB. Now, first I should never write, I named the only written the name of one triangle, not the other triangle. I'll tell you why. See, what I'll do, I'll prove this triangle similar orally first. Angle APC, congruent angle DPB, vertical opposite angles. And then you can see here, this angle PAC and angle PDB, they are congruent because the angles inscribed in the same arc. You can see this angle A is an inscribed angle. Angle D is an inscribed angle. Both are inscribed in the same arc. So naturally they are congruent. So naturally अगर PAC नेम किया तो मैचिंग में नेम P का मैचिंग P आएगा ये ट्रायंगल में, A किसका साथ कॉन्ग्रुएंट है, D इसका साथ, तो अगर A सेकंड है तो D सेकंड आएगा, PDB. Okay, you can see now angle APC is congruent to angle DPB. What's the reason, children? Vertically opposite angles. Vertically opposite angles. Vertically opposite angles. Then, children, your angle PAC, you can see your angle PAC. It is congruent to angle PDP. PDP. What's the reason, children? Angles inscribed in the same arc. Angles inscribed in the same arc, children. Angles inscribed in the same arc. So can I say both the triangles are similar? Triangle PAC, similar triangle PDP. By what test, children? By AA test of similarity. Now, since AA test of similarity, since both these triangles are similar, I can say corresponding sides are in proportion. PA upon PD equal PC upon PB. I think this is what I want. If I cross multiply, I'll get the answer. Corresponding sides of corresponding sides of similar triangles. Corresponding sides of similar triangles. So I can say, therefore, PA into PB, PC into PD. You got your answer, children. You got your answer. So this theorem of internal division of chord gets over. We move to the next theorem, children. Now this point P, it divides segment AB into, it doesn't lie on segment AB. This P, it doesn't lie on segment AB. But segment AB is from A to B. So this P doesn't lie on segment AB, but it lies on line AB. It lies on line AB. This P is set to divide this AB, segment AB, externally. P is dividing AB externally into two parts. Which are the two parts, children? P divide कर रहा है, तो P common होगा दोनों parts के लिए. तो PA एक part हो गया, PB एक part हो गया. I hope people are understanding. So P is dividing segment AB externally into two parts. Which are the two parts? PA and PB. Suppose there is one segment XY here. There is one segment XY, okay? There is one segment XY, okay? And on this segment XY, please have a look at this. This is one segment XY, okay? And on this segment XY, A lies. A is dividing segment XY externally. A is dividing. So A should be part of the two parts. A should be common to the two parts. A is dividing XY externally. So the two parts will be AX and AY. Are you getting me here? I hope people understand. Once again, I repeat. P doesn't lie on segment AB, but P lies on line AB. P is dividing AB into two parts. P divide कर रहा है, तो P common आने चाहिए दोनों parts के लिए. तो दोनों parts कैसे लेंगे? PA और PB. वैसे इधर एक segment XY है. A doesn't lie on segment XY, but it lies on line XY. A is dividing segment XY into two parts. A divide कर रहा है, तो A should be common to the two parts. तो एक पार्ट AY हो गया, एक पार्ट AX हो गया. तो इधर P को बोलते हैं पॉइंट ऑफ एक्सटर्नल डिविजन ऑफ AB. इधर A को बोलूंगा पॉइंट ऑफ एक्सटर्नल डिविजन ऑफ XY. So here the theorem of external division of a chord. So what does it mean? Okay, I'll say two chords of the same circle intersect at a point outside the circle. Two chords of the same circle intersect at a point outside the circle. Then product of the divided parts of one chord, okay, is equal to product of the divided parts of other chord. I'll just write it down and then show it to you. I can see here, children, if two chords of the same circle, suppose this is your circle, okay, and two chords of the same circle, like this is one chord AB, got it? This is the other chord CD. Now, these two chords of the same circle there, are they intersecting inside the circle, children? No. These chords are not at all intersecting. Chord AB and chord CD, they are not intersecting inside a circle. But don't you agree? The lines containing them will intersect. The lines containing them will intersect at a point outside the circle. The lines containing them will intersect at a point outside the circle. You can see it. These lines containing them intersect at a point outside the circle. So you can see, children, these two chords, they are not intersecting inside a circle, but the lines containing them intersect at point P outside the circle. So now you can see this P is dividing chord AB into two parts. Which are the two parts? PA and PB. P is dividing it externally. P is dividing chord CD into two parts. Which are the two parts? PC and PD. Product of the divided parts of one chord, PA into PB equal PC into PD. So given, I'll just write like this. Either chords, chord AB, chord. Okay, I'll put it like this. The sequence containing chord AB and the sequence containing chords AB and CD, chords AB and CD intersect at point P outside the circle, at point P outside the circle. So what I want to prove? Outside the circle. Then product of the divided parts, since P is dividing AB externally, P is common part. So how it should be, children? Prove that PA into PB is equal to PC into PD. What is product of the divided parts of one chord is equal to product of the divided parts of other chord. You have to prove this. Are you getting me here? Now you can see here, children, how do we go about? So I told you, children, the second last line should be the ratio. Last line should be this. Proof ka last line. When you think about the proof, okay, the last line of the proof should be. The last line of the proof should be ratio, this PA into PB equal PC into PD. Second last line must have been a ratio. Ratio equal दिखाने के लिए you have to prove that triangle similar. So this big segments and the small segment should be the sides of the triangle. How the triangles will take. So I get an idea. If I draw C to B, can you see one triangle PBC? PC big side and PB small side. And likewise, if I draw this, you can see this again. Can you see this triangle PDA? It involves a big segment PA and the small segment PD. So naturally, there are two triangles formed now. If this two, like what you did construction, draw segment AD and segment BC, okay? And because of that, there are two triangles formed. Look, very simple. Common angle. These two are angles inscribed in the same arc. So both the triangles are similar. Suppose a big triangle, PAD, if I name it, okay? If I name one triangle as PAD, if I name one triangle as PAD, in triangle, if I name this triangle PAD, what should be the name of the second triangle, children? P ka matching part is P. A ka C. A is written second PC, B. Okay, now look here. Angle, I want people to pay attention here. Angle P, congruent to angle P. What's the reason, children? It should be a common angle. Common angle. Then angle PAD is congruent to angle PCB. Angles inscribed in the same arc. In the same arc are congruent. So both the triangle PAD is similar to triangle PCB by a test of similarity. Therefore, PA upon PC equal, if I take PD here, PD upon PB. I think these are the four segments, corresponding sides of similar triangles. Corresponding sides of similar triangles. Now cross multiply PA into PB equal PC into PD. I think we got the answer, children. Okay, this is theorem of external division of the chords. This is theorem of external division of the chords. This is theorem of external division of the chords. Okay, now we come to the next of this theorem, children. We go to the next of this theorem. A very important theorem, and this theorem is surely asked in the exam. Okay, but in the way it is asked, not in a statement form or anything, it will be given and prove that. Okay, the same way, the way it is written here, it will be asked in the same form. Point E is any point in the exterior of a circle. Can you see a circle? E is any point in the exterior of a circle. A secant through E intersects the circles in points A and B. A secant through E intersects the circles in points A and B. I will draw a secant. This is a secant, children. A secant through E intersects the circle in points A and B. Then they say, and a tangent through E. And the tangent through it touches the circle at T. And the tangent through E touches the circle. Tangent through E touches the circle at T. Tangent through E. You can see if this is a tangent through E. It touches a circle at T. Now what they're saying, children? They're saying EA. Can you see the segment EA? Into EB. Can you see this EB is equal to ET squared? Equal to ET squared. Now, ET square is this, okay? So always remember, children, the last line should be this. When you try to write the proof, the last line should be ET square. See, always remember one like a trick. जब मालूम है ET square equal A into EB, मतलब दो ट्रायंगल को सिमिलर प्रूव करना है, तो दिस ET square ना ये ET दो ट्रायंगल देनी चाहिए, मतलब ET का एक दो ट्रायंगल का साइड रहनी चाहिए. ET should be a side of one triangle. तो naturally देखो इधर अगर ET को अगर मैंने ज्वाइन किया T to B, got it? So ET is the side of the big triangle. And if I join T to A, you can see here your ET has become a side of the small triangle. So ET is the side of two different triangles. Okay. So construction, what I'll do? This construction, we have to do this construction. Okay. Construction. Draw segment BT and segment AT. This is our construction, okay? We have done the construction, okay, children? We have done the construction, okay? Construction. Now we have to write the proof for it, children. Now you can see these two triangles. One is triangle, big triangle, another is small triangle. Angle E is common to angle E, common angle. Then, children, look, this is an angle between a tangent and a chord. Angle between a tangent and a chord. And this is an angle. Please have a look at this. This is an inscribed angle. Okay. This tangent secant angle intercepts arc AT. This inscribed angle intercepts arc AT. So both these angles are equal. So how is these two angles are equal? So now it's up to you. How are you going to write? Which triangle's name you want to write first? Suppose you write the name of the small triangle in triangle ETA. So what should be the name of the big triangle, children? E matching E, T ka matching B, okay, and EBT, okay? You can see the two triangles, children, ETA and EBT, ETA and EBT. Now you can see here, children, this angle E is congruent to angle E. I can say common angle. You can go for three-letter name also. Doesn't matter, children. Common angle. You want to go for three-letter name, it should be TEA. So BET. Got it? Then, children, another one, angle ETA congruent to angle EBT. You can always call this as angles in alternate segments. Angles in alternate segments. All angles in alternate segments, or tangent secant theorem. Tangent secant theorem. You can also call it that. Therefore, triangle ETA is similar to triangle EBT by AA test of similarity. Now, once the triangles are similar, the corresponding sides are in proportion. ET upon EB equal AT upon BT equal EA upon ET, corresponding sides of similar triangles. Corresponding sides of similar triangles, corresponding sides of similar triangles. The first ratio and the last ratio, I think, will give me ET squared. So I rewrite ET upon EB equal EA upon ET. Now what will happen? EA upon ET, sorry, EA upon ET, cross multiply, ET squared equal EA into EB. A very important, children. Surely this can be asked in your exam. Okay, with this, your theorems of third chapter comes